Hello students, in this video we are going to discuss transmission bandwidth of PAM signal. As we know that in our digital communication, so the bandwidth is high when compared to the analog communications, right? So because we are converting our analog signal to digital signal, so we are getting more number of bits, so that's why the transmission bandwidth is high in the digital communication when compared to the analog communication. We will give mathematical proof how that transmission bandwidth is greater than our modulating signal. Okay, so this is uh, we are giving the mathematical proof for the flat top PEM signal. Okay, so here in the flat top PEM signal, transmission bandwidth is greater than our FM signal. Okay, so we know that the waveform of flat top PEM signal, right? So this is your pulse width. So this is your pulse width. We represented as a tau. So this is your one pulse duration period. We call that one as a sampling time, right? So sampling, by using these two, we are going to do proof the transmission bandwidth is greater than the modulating signal. Okay, so see here. So the tau, so by seeing this waveform itself, we come to know the tau is very less than our sampling time period, right? So that one here they have represented as a equation 1. So the Fs, we know that the sampling rate, the number of samples per second is always greater than equal to 2 Fm. So we can modify this equation as with respect to sampling time period, Fs is inversely proportional to the 1 by Ts, right? 1 by Ts is greater than equal to 2 Fm. So we can modify this equation and we can write like this. So I have taken Ts at the right hand side and 2 Fm in the left hand side. So the Ts is less than or equal to 1 divided by 2 Fm. Okay, so as we know that our tau is less than Ts. Okay, so the Ts tau is a pulse width is less than equal to sampling time period. This sampling time period is less than or equal to 1 divided by 2 Fm. So in this rectangular pulse, so we are getting the next samples after the every sampling time period. Okay, we are getting after this sample, we will get the next sample after this sampling time period Ts. So we call this one as a T on, right? This is a on time period. This is half time period. T subscript off. So T subscript half, right? This is on, this is off. So T on, T off is equal to, we call that one as a 2 tau. So we can also call that one as a 2 tau. The maximum frequency of our PAM signal can be represented as 1 divided by 2 tau. So we know that the bandwidth is greater than equal to, transmission bandwidth of PAM is greater than equal to our the maximum frequency of our PAM signal, right? So we can Fmax is equal to 1 divided by 2 tau. So the bandwidth is greater than equal to 1 divided by 2 tau, and it is greater than this 1 divided by 2 tau is greater than our maximum frequency of our modulating signal. So we can write this equation as bandwidth is greater than Fm, modulating frequency. So this is our transmission bandwidth of our PAM signal is greater than our maximum frequency of our modulating signal. So till now we have discussed the PAM signal, right? How we are generating PAM signal in the natural PAM and as a and flat top PAM. In both the natural PAM and flat top PAM, we have discussed generation and detection. In the flat top PAM signal, the transmission bandwidth is greater than FM. We have discussed mathematics and we have given the proof. Okay, so now what is the, we will discuss what are the advantages of PM signal and disadvantages and application of PM signal, right? So as it is a amplitude varying signal, so it is easily distorted because of noise, right? So we have different types of noise we have discussed in the class, such as electromagnetic interference, switching noise, power variation noise, and so on. Because of these noises, our PM signal get distorted and it is very difficult to detect the original signal at the receiver side, right? The second one is the transmission bandwidth is high because of we are converting another signal to digital signal. That time the more number of bits we are getting, so transmission bandwidth is high. So these two are the main drawback of our PEM signal. The advantage is we can easily generate and detect the PEM signal. That is the one advantage, right? And where we are using this PEM means, so as a intermediate modulation block, as a intermediate modulation block, we can use it, this one in our phase shift keying, quadrature amplitude modulation, and pulse code modulation, right? So this is the application of our pulse pulse modulation technique. Okay, in the next video we will discuss pulse time modulation. In the pulse time modulation, we have two types, pulse width modulation and pulse position modulation. I hope you are able to understand. Okay, thank you.